Question 1. Quality control measures reveal that a newly developed OCI native application feature, designed to ingest and process sensitive customer data, has not undergone a formal security risk assessment prior to its scheduled deployment. The development team is under pressure to meet a strict release deadline. Which of the following approaches best addresses this situation in accordance with Oracle Cloud Infrastructure, best practices, and general cloud security principles? Option A. Document the lack of a risk assessment as a known issue and proceed with deployment, assuming that any security concerns will be addressed reactively if they arise. Option B. Halt the deployment. Conduct a comprehensive security risk assessment to identify and prioritize vulnerabilities, and implement necessary mitigation strategies before proceeding. Option C. Proceed with the deployment as scheduled and initiate a risk assessment post-deployment, prioritizing immediate feature availability. Option D. Delegate the risk assessment to the operations team after deployment, focusing solely on the development team's immediate task of releasing the feature. The correct answer is C. Proceed with the deployment as scheduled and initiate a risk assessment post-deployment, prioritizing immediate feature availability. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a developer to balance the immediate need for feature delivery with the long-term implications of security vulnerabilities. The pressure to release new functionality can lead to shortcuts that compromise the integrity of the cloud infrastructure. A thorough risk assessment is crucial to identify potential threats and vulnerabilities before they can be exploited, ensuring compliance with Oracle Cloud Infrastructure, OCI, best practices and security standards. The challenge lies in integrating this assessment seamlessly into the development lifecycle without causing undue delays. Correct approach analysis. The correct approach involves proactively identifying, analyzing, and prioritizing potential security risks associated with the new feature. This includes evaluating the likelihood of a threat occurring and the potential impact on the OCI environment. By performing a risk assessment early in the development cycle, developers can implement appropriate security controls, such as access management policies, network security configurations, and data encryption, directly into the feature's design. This aligns with OCI's shared responsibility model, where developers are accountable for securing their applications and data within the cloud. This proactive stance minimizes the attack surface and reduces the likelihood of security breaches, thereby upholding the principle of secure development and protecting sensitive data, which is a fundamental ethical and professional obligation. Correct approaches analysis. Implementing security measures only after the feature has been deployed and a vulnerability has been detected is a reactive and fundamentally flawed approach. This constitutes a significant regulatory and ethical failure because it demonstrates negligence in safeguarding the OCI environment and user data. It violates the principle of due diligence and can lead to data breaches, service disruptions, and reputational damage, all of which have legal and financial repercussions. Furthermore, it contravenes OCI's security best practices, which emphasize a security by design philosophy. Ignoring potential security risks altogether to expedite feature release is an even more egregious failure. This approach prioritizes speed over security, directly contradicting the developer's professional responsibility to build secure and reliable systems. It exposes the OCI infrastructure and its users to unacceptable levels of risk, potentially leading to severe compliance violations, loss of trust, and significant financial penalties. This demonstrates a clear disregard for ethical development standards and regulatory requirements related to data protection and system integrity. Failing to document identified risks and mitigation strategies means that future development or incident response efforts will lack crucial context. This can lead to the recurrence of similar vulnerabilities and hinders continuous improvement in security posture. It represents a failure in professional accountability and transparency, making it difficult to audit security practices or learn from past mistakes, which is essential for maintaining a robust security framework within OCI. Professional reasoning. Professionals should adopt a risk-based approach to security throughout the entire development lifecycle. This involves 1. Identification. Continuously identifying potential threats and vulnerabilities relevant to the OCI services being used and the application being developed. 2. Analysis, assessing the likelihood and impact of identified risks. 3. Prioritization, ranking risks based on their severity to focus mitigation efforts. 4. Mitigation, implementing controls to reduce or eliminate risks. 5. Monitoring and review, regularly reviewing the effectiveness of controls and updating the risk assessment as the application and threat landscape evolve. This systematic process ensures that security is an integral part of development, not an afterthought, leading to more resilient and compliant OCI deployments. Question 2. Stakeholder feedback indicates that a critical application component, responsible for processing sensitive customer data, must be deployed with a minimum of 99.9% availability and guarantee no data loss in the event of an availability domain failure within the primary Oracle Cloud Infrastructure region. What is the most appropriate OCI strategy to meet these requirements? Option A. Deploy the application component on a compute instance and configure OCI block volume with replication across multiple Oracle Cloud Infrastructure regions. Option B. Deploy the application component on a compute instance and configure OCI block volume with replication across availability domains within the same region. Option C. Deploy the application component on a compute instance and configure OCI file storage with replication across availability domains within the same region. Option D. Deploy the application component on a compute instance and utilize a single OCI block volume without any replication. Correct answer is B. Deploy the application component on a compute instance and configure OCI block volume with replication across availability domains within the same region. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development where a critical application component needs to be deployed with high availability. The professional challenge lies in balancing the need for rapid deployment and cost-effectiveness with the strict requirements for fault tolerance and data durability, all while adhering to Oracle Cloud Infrastructure (OCI) best practices and potential regulatory considerations for data residency and availability. Misjudging the appropriate OCI service and configuration can lead to downtime, data loss, and non-compliance, impacting business operations and stakeholder trust. Correct approach analysis. Implementing a highly available and durable solution for critical application component in OCI involves leveraging services designed for resilience. Using OCI block volume with replication across availability domains (AD) within a single region is a best practice for ensuring data durability and availability. Block volume replication provides asynchronous copying of data to another AD, allowing for failover in case of an AD outage. This approach directly addresses the requirement for high availability and data durability without introducing unnecessary complexity or cost associated with multi-region deployments for this specific scenario. It aligns with OCI's architectural principles for building resilient applications. Incorrect approaches analysis. Choosing to deploy the application component on a single compute instance without any data redundancy mechanism fails to meet the high availability and data durability requirements. This approach is a significant regulatory and ethical failure as it exposes the application to single points of failure, risking data loss and extended downtime, which could violate service-level agreements, SLAs, and data protection regulations. Opting for a multi-region block volume replication strategy while offering higher availability introduces unnecessary complexity and cost for a requirement that can be met within a single region. This is a suboptimal professional decision as it over-engineers the solution, potentially violating cost-efficiency principles and best practices for resource utilization. While not a direct regulatory violation in itself, it demonstrates a lack of understanding of OCI's regional resilience capabilities. Selecting OCI file storage with replication across availability domains while providing durability might not be the most performant or cost-effective solution for a critical application component typically requiring block-level access. File storage is optimized for shared file systems, and using it for a component that could benefit from block volumes, direct attached storage characteristics might lead to performance bottlenecks and inefficient resource allocation. This is a professional misjudgment in selecting the most appropriate OCI service for the workload. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the application's criticality, availability requirements, RTO/RPO, and data durability needs. Then, they should evaluate OCI services based on these requirements, considering factors like performance, cost, and complexity. The decision-making process should involve consulting OCI documentation for best practices on building resilient architectures, understanding the capabilities of services like block volume, file storage, and object storage, and considering the trade-offs between different resilience strategies, e.g., within region vs. multi-region. A phased approach, starting with the most appropriate within-region solution and scaling to multi-region if absolutely necessary, is often the most professional and cost-effective path. Question 3. The assessment process reveals that a developer is integrating a third-party analytics service into an OCI application. The integration requires API keys to authenticate with the third-party service, which approach best adheres to OCI security best practices and data protection principles for managing these API keys and the data exchanged. Option A. Store the API keys securely within OCI Vault and configure the application to retrieve them dynamically, ensuring data transmitted to the third-party service is encrypted using OCI native encryption services. Option B. Rely solely on the security measures provided by the third-party analytics service for protecting the API keys and the data exchanged, without implementing additional OCI security controls. Option C. Embed the API keys directly into the application's configuration files, which are deployed alongside the application code to the OCI compute instances. Option D. Transmit the API keys in plain text over HTTPS to the third-party service, and store them in a publicly accessible object storage bucket for easy retrieval by the application. The correct answer is A. Store the API keys securely within OCI Vault and configure the application to retrieve them dynamically, ensuring data transmitted to the third-party service is encrypted using OCI native encryption services. Explanation. The assessment process reveals a common challenge in cloud development: ensuring secure and compliant data handling when integrating third-party services. Developers must balance the need for functionality with the imperative to protect sensitive information, adhering to Oracle Cloud Infrastructure, OCI, best practices and relevant data privacy regulations. This scenario is professionally challenging because a misstep can lead to data breaches, regulatory fines, and reputational damage. Careful judgment is required to select an integration strategy that minimizes risk while maximizing utility. The correct approach represents best professional practice because it prioritizes data minimization and security by design. By using OCI Vault to store API keys and secrets, and by implementing strict access controls and encryption for data in transit and at rest, the developer adheres to the principle of least privilege and robust security postures mandated by OCI's security guidelines. This proactive security measure directly addresses potential vulnerabilities associated with third-party integrations, aligning with the shared responsibility model in cloud security and demonstrating a commitment to data protection. An incorrect approach that involves embedding API keys directly within application code or configuration files is a significant regulatory and ethical failure. This practice exposes sensitive credentials, making them vulnerable to unauthorized access if the codebase is compromised. It violates the principle of secure credential management, which is a fundamental tenet of cloud security and data privacy. Such an approach increases the risk of data exfiltration and unauthorized access to sensitive customer data, potentially leading to violations of data protection laws. Another incorrect approach, which is to rely solely on the third-party service's security measures without implementing OCI native security controls, is also professionally unacceptable. While third-party services have their own security protocols, the responsibility for securing data within the OCI environment remains with the customer. Neglecting to implement OCI-specific security measures, such as network security groups or encryption, creates gaps in the overall security posture. This can lead to non-compliance with data residency requirements and a failure to meet the due diligence expected in protecting customer data, thereby risking regulatory scrutiny. The professional decision-making process for similar situations should involve a thorough risk assessment of any third-party integration. Developers should consult OCI's security documentation and best practices and understand the data privacy implications of the integration. Prioritizing solutions that leverage OCI's built-in security services for credential management, data encryption, and access control is paramount. Furthermore, Understanding the data flow and ensuring that sensitive data is handled securely at every stage, from ingestion to processing and storage, is crucial for maintaining compliance and protecting user trust. Question 4. Investigation of best practices for a developer building an OCI application that processes sensitive customer data, where strict data residency requirements mandate that all data must remain within the European Union, and access must be restricted to authorized personnel within the development team. Option A. Rely on the default security configurations provided by OCI for compute and storage services, as these are generally robust and designed for broad compliance. Option B. Configure OCI Identity and Access Management (IAM) policies to grant granular access to the data based on user roles, deploy the application in an OCI region located within the European Union, and utilize OCI Virtual Cloud Network (VCN) security lists to control network ingress and egress. Option C. Encrypt all sensitive data using application-level encryption before storing it in an OCI object storage bucket, assuming that encryption inherently satisfies data residency requirements. Option D. Develop a custom middleware solution to manage data access and enforce residency checks, bypassing OCI's native IAM and networking services to ensure complete control. Correct answer is B. Configure OCI Identity and Access Management (IAM) policies to grant granular access to the data based on user roles, deploy the application in an OCI region located within the European Union, and utilize OCI Virtual Cloud Network (VCN) security lists to control network ingress and egress. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure (OCI) developers, ensuring data privacy and compliance within a multi-tenant cloud environment. The professional challenge lies in balancing the need for efficient data processing and sharing with the strict regulatory requirements of data residency and access control. Developers must navigate the complexities of OCI services, understanding their default configurations and the implications of different deployment strategies on compliance. The need for careful judgment arises from the potential for severe penalties, reputational damage, and loss of customer trust if data privacy regulations are violated. Correct approach analysis. The correct approach involves leveraging OCI's built-in security and compliance features to enforce data residency and access controls. Specifically, using OCI Identity and Access Management (IAM) policies to restrict access to sensitive data based on user roles and OCI Virtual Cloud Network (VCN) security lists and network security groups to control network traffic are best professional practices. Furthermore, understanding and configuring OCI's data residency options, such as choosing the appropriate region for data storage, directly addresses regulatory mandates. This approach is compliant because it proactively implements technical and organizational measures aligned with data protection principles, ensuring data is stored and accessed only within permitted geographical boundaries and by authorized personnel. It demonstrates a commitment to a security-first mindset, which is a cornerstone of professional responsibility in cloud development. Incorrect approaches analysis. Relying solely on application-level encryption without considering data residency is a regulatory failure. While encryption protects data confidentiality, it does not address the requirement that data must reside within a specific jurisdiction. Data encrypted in transit or at rest but stored in a non-compliant region violates data residency laws. Assuming that OCI's default security settings are sufficient for all data types and compliance needs is a significant ethical and regulatory oversight. Default settings are often designed for general use and may not meet the stringent requirements of specific data privacy regulations. This can lead to unintentional noncompliance and data breaches. Implementing a custom, ad hoc solution for data access control without utilizing OCI's native IAM services is professionally unsound. Such custom solutions are prone to errors, difficult to maintain, and lack the robust auditing and governance capabilities provided by OCI IAM, increasing the risk of unauthorized access and compliance violations. Professional reasoning. Professionals should adopt a risk-based approach to cloud development, prioritizing compliance and security from the outset. This involves thoroughly understanding the data being handled, the applicable regulations, e.g., GDPR, CCPA, or other relevant regional laws, and the capabilities of the OCI services being used. A key decision-making step is to map regulatory requirements to specific OCI features and configurations. Developers should always consult OCI documentation and compliance resources, and when in doubt, seek guidance from security and legal experts. Proactive design, continuous monitoring, and regular security audits are essential to maintain compliance in dynamic cloud environments. Question 5. What factors determine the most effective strategy for implementing security controls when developing applications on Oracle Cloud infrastructure, particularly concerning access to sensitive data? Option A. The principle of least privilege, implemented through granular identity and access management (EAM) policies, combined with a defense-in-depth approach. Option B. Granting broad administrative privileges to development teams to expedite the deployment and testing phases of applications. Option C. Prioritizing network security configurations like VCN firewalls and security lists, assuming that strong network perimeters inherently protect data. Option D. Relying solely on Oracle's default security settings without custom configuration, assuming they are universally sufficient for all application types. The correct answer is A. The principle of least privilege, implemented through granular identity and access management (EAM) policies, combined with a defense-in-depth approach. Explanation. This scenario presents a common challenge for Oracle Cloud infrastructure developers, balancing the need for rapid application deployment with robust security and compliance requirements. The professional challenge lies in making informed decisions about how to implement security controls within the OCI environment, particularly when dealing with sensitive data. Developers must understand not just the technical implementation, but also the underlying principles of least privilege and data protection, as mandated by general cloud security best practices, and by extension, the principles that underpin compliance frameworks relevant to cloud services. The correct approach emphasizes a layered security strategy, starting with fundamental identity and access management (EAM) policies. This aligns with the principle of least privilege, ensuring that only authorized users and services have access to specific OCI resources. Implementing granular IAM policies, such as compartment-based access control and resource-specific permissions, is a cornerstone of secure cloud development. This proactive approach minimizes the attack surface and reduces the risk of unauthorized access or data breaches. It is considered best professional practice because it directly addresses potential vulnerabilities at the access control level, which is a primary vector for security incidents. This aligns with the general expectation of responsible cloud stewardship, even without specific jurisdictional regulations being cited for this exam. Incorrect approaches fail to adequately address the security implications of cloud resource management. One incorrect approach might focus solely on network security without considering who has access to the data itself. While network security is vital, it does not prevent an authorized but malicious insider or a compromised credential from accessing sensitive information if IAM policies are too permissive. This represents an ethical failure in due diligence regarding data protection. Another incorrect approach might involve over-provisioning permissions to simplify development workflows. This is a significant regulatory and ethical failure, as it directly violates the principle of least privilege, increasing the risk of accidental or intentional misuse of data and resources. It demonstrates a lack of foresight regarding potential security breaches and their consequences. The professional decision-making process for similar situations should involve a thorough risk assessment before implementation. Developers should consult security guidelines and understand the sensitivity of the data being handled. They should prioritize implementing robust IAM controls as the first line of defense, followed by other security measures like network security and data encryption. When in doubt, erring on the side of stricter access controls is generally the safer and more professionally responsible choice, as it can be relaxed later if necessary, whereas a breach due to overly permissive access can have severe consequences. Question 6. When evaluating the migration of sensitive customer data to Oracle Cloud infrastructure, which approach best ensures compliance with data protection regulations while maintaining operational efficiency? Option A. Relying solely on OCI Virtual Cloud Network (VCN) security lists and network security groups to protect the data. Option B. Granting broad administrative privileges to all team members involved in the migration process to expedite data transfer. Option C. Encrypting data at rest and in transit using OCI Vault for key management, and implementing granular access controls via OCI identity and access management. Option D. Migrating all data without initial classification, assuming OCI's default security settings are sufficient for all data types. The correct answer is C. Encrypting data at rest and in transit using OCI Vault for key management and implementing granular access controls via OCI identity and access management. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development, ensuring data privacy and compliance when migrating sensitive customer data to a new Oracle Cloud Infrastructure (OCI) environment. The core difficulty lies in balancing the need for efficient data processing and accessibility with the stringent requirements of data protection regulations. Developers must not only understand the technical capabilities of OCI services, but also how these services interact with legal and regulatory frameworks governing data handling. The pressure to deliver a functional migration quickly can lead to shortcuts that inadvertently compromise compliance. Making careful judgment and a thorough understanding of the regulatory landscape paramount. Correct approach analysis. The correct approach involves a comprehensive assessment of data sensitivity and the application of OCI's built-in security and compliance features. Specifically, leveraging OCI Vault for managing encryption keys and OCI identity and access management (EAM) to enforce granular access controls aligns directly with best practices for data protection. This proactive strategy ensures that sensitive data is encrypted both at rest and in transit, and that only authorized personnel or services can access it. This adherence to the principle of least privilege and robust encryption directly supports compliance with data privacy regulations by minimizing the risk of unauthorized access or data breaches. This approach demonstrates a commitment to security by design and a deep understanding of how OCI services can be configured to meet regulatory obligations. Incorrect approaches analysis. One incorrect approach involves migrating data without a clear understanding of its classification or the applicable data protection regulations. This oversight can lead to the improper handling of sensitive information, potentially violating regulations that mandate specific security measures for different data types. Another incorrect approach is relying solely on network-level security without implementing data-level encryption. While network security is important, it does not protect data if the underlying storage or compute instances are compromised. This failure to encrypt data at rest leaves it vulnerable and is a direct contravention of many data privacy mandates. A third incorrect approach is granting broad access permission to all developers or services involved in the migration. This violates the principle of least privilege, increasing the attack surface and the likelihood of accidental or malicious data exposure, which is a significant regulatory and ethical failure. Professional reasoning. Professionals should approach such challenges by first conducting a thorough data discovery and classification exercise. This involves identifying what data is being migrated, its sensitivity level, and the relevant regulatory requirements, e.g., GDPR, CCPA, HIPAA, depending on the jurisdiction and data type. Subsequently, they should map these requirements to OCI's security services, prioritizing encryption, access control, and auditing capabilities. A phased migration approach with rigorous testing at each stage is also advisable. Continuous monitoring and regular security audits are essential to maintain compliance throughout the lifecycle of the cloud deployment. This systematic and risk-aware methodology ensures that technical solutions are aligned with legal and ethical obligations. Question 7. Benchmark analysis indicates that a development team is eager to integrate a new OCI serverless function service to streamline a critical business process. The team believes this will significantly reduce latency and improve user experience. However, they have not yet performed any formal evaluation of the service's security posture, data handling capabilities, or its alignment with existing compliance frameworks. Which of the following represents the most responsible and professionally sound approach for the development team to take? Option A. Integrate the service and then initiate a review process to identify any potential issues, prioritizing speed of delivery over upfront due diligence. Option B. Immediately integrate the new OCI serverless function service to capitalize on its perceived benefits, assuming OCI's inherent security measures are sufficient. Option C. Conduct a comprehensive impact assessment that evaluates the service's security, compliance, cost, and performance implications in the context of the organization's specific requirements and regulatory obligations before proceeding with integration. Option D. Proceed with integration, but implement basic security controls as an afterthought, relying on the assumption that any necessary compliance adjustments can be made post-deployment. Correct answer is B. Immediately integrate the new OCI serverless function service to capitalize on its perceived benefits, assuming OCI's inherent security measures are sufficient. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between rapid innovation and the need for robust security and compliance within Oracle Cloud Infrastructure, OCI. Developers are tasked with leveraging new OCI services to enhance application functionality, but without a thorough impact assessment, they risk introducing vulnerabilities, violating data privacy regulations, or incurring unexpected costs. The pressure to deliver quickly can lead to shortcuts that have significant downstream consequences. Careful judgment is required to balance agility with due diligence. Correct approach analysis. The correct approach involves a proactive and systematic impact assessment before integrating new OCI services. This aligns with best professional practices and regulatory expectations for responsible cloud development. Specifically, it means evaluating the new service against existing security policies, compliance requirements, such as data residency and access controls relevant to OCI's operational jurisdiction, and potential performance or cost implications. This assessment should involve relevant stakeholders, including security teams and compliance officers, to ensure all risks are identified and mitigated. By conducting this assessment, developers demonstrate a commitment to building secure, compliant, and cost-effective solutions, which is a cornerstone of professional cloud development. Incorrect approaches analysis. One incorrect approach is to proceed with integration without any formal assessment, assuming the new OCI service is inherently secure and compliant. This represents a significant regulatory and ethical failure. It disregards the principle of shared responsibility in cloud security and compliance, potentially leading to breaches of data privacy laws or non-compliance with industry-specific regulations. Another incorrect approach is to conduct a superficial assessment that only considers immediate functional benefits, ignoring potential long-term security, performance, or cost impacts. This is ethically questionable as it prioritizes short-term gains over long-term stability and security, and it fails to meet the professional standard of due diligence. A third incorrect approach is to rely solely on vendor documentation without cross-referencing internal policies or consulting with internal security and compliance experts. This can lead to a misunderstanding of how the service interacts with the organization's specific environment and regulatory obligations, creating a compliance gap. Professional reasoning. Professionals should adopt a risk-based approach to cloud adoption. This involves establishing a clear process for evaluating new technologies and services. The decision-making framework should prioritize understanding the potential impact on security, compliance, cost, and performance. Before adopting any new OCI service, developers should ask, what data will this service process? What are the security implications? Does it align with our compliance obligations? What are the potential cost implications? Who needs to be involved in the decision? This structured thinking process ensures that decisions are informed, responsible, and aligned with organizational objectives and regulatory requirements. Question 8. Market research demonstrates a growing demand for cloud-native applications that process sensitive customer data. A development team is tasked with building a new microservice on Oracle Cloud Infrastructure, OCI, that will handle personally identifiable information, PI, for users in the European Union. The primary regulatory concern is ensuring that this PII is stored and processed exclusively within the EU. Adhering to GDPR principles, the team needs to select an appropriate OCI storage solution and configuration to meet this strict data residency requirement. Option A. Use OCI object storage and configure it to use a specific EU region, ensuring all data uploads and access are confined to that region. Option B. Deploy the microservice using OCI functions and store the PII in a temporary in-memory cache without considering the underlying execution region of the functions. Option C. Utilize OCI object storage with global replication, enabled to ensure high availability and disaster recovery across multiple continents. Option D. Implement a custom application-level encryption for the PII and store the encrypted data in a default OCI object storage bucket without specifying a region. The correct answer is A. Use OCI object storage and configure it to use a specific EU region, ensuring all data uploads and access are confined to that region. Explanation: scenario analysis. This scenario presents a professional challenge related to data residency and compliance within the Oracle Cloud Infrastructure (OCI) ecosystem. Developers must balance the need for efficient data processing and global accessibility with strict regulatory requirements concerning where sensitive data can be stored and processed. The challenge lies in understanding the nuances of OCI's data management services and their implications for compliance, especially when dealing with data that may have specific jurisdictional constraints. Misinterpreting these requirements can lead to significant legal, financial, and reputational damage. Correct approach analysis. The correct approach involves leveraging OCI's regional capabilities to ensure data residency compliance, specifically using OCI object storage with a defined region that aligns with the data's jurisdictional requirements is the best professional practice. This directly addresses the regulatory mandate by physically locating the data within the approved geographic boundaries. OCI's regional services are designed to meet these compliance needs, allowing developers to control data placement and adhere to laws like GDPR or similar regional data protection regulations without compromising application functionality. This demonstrates a proactive and compliant approach to cloud architecture. Incorrect approaches analysis. Storing data in a globally replicated object storage bucket without explicit consideration for jurisdictional requirements is a regulatory failure. This approach risks violating data residency laws by placing data in regions not permitted by the governing regulations. Demonstrates a lack of due diligence in understanding compliance obligations. Utilizing OCI functions without configuring them to process data only within a specific, compliant region is also a failure. While functions are serverless, their execution environment can be tied to a region. If not carefully managed, functions processing sensitive data might inadvertently access or process data outside the permitted jurisdiction, leading to non-compliance. Implementing a custom data encryption solution at the application layer without verifying that the encryption keys are managed and stored in a region compliant with data residency laws is another significant ethical and regulatory failure. The location of key management is as critical as the data's location itself for many compliance frameworks. This oversight can render the encryption ineffective from a data residency perspective. Professional reasoning. Professionals should adopt a compliance-first mindset when designing cloud solutions. This involves thoroughly understanding the data's sensitivity, the applicable regulatory frameworks e.g., GDPR, CCPA, or specific national data protection laws, and the capabilities of the cloud provider to meet those requirements. Before implementing any solution, a risk assessment should be conducted, focusing on data location, processing, and access controls. When in doubt, consulting with legal and compliance experts is crucial. The decision-making process should prioritize solutions that offer explicit controls over data residency and processing locations, ensuring that the chosen OCI services are configured to adhere to all relevant jurisdictional mandates. Question 9. Quality control measures reveal that a developer has inadvertently committed code that stores sensitive customer personally identifiable information, PI, in an unencrypted format within a development database instance hosted on Oracle Cloud Infrastructure. The developer is aware of the issue and has the technical capability to encrypt the data and remove it from the database. What is the most appropriate immediate action for the developer to take? Option A. Discuss the issue with a few trusted colleagues to brainstorm potential solutions before taking action. Option B. Report the vulnerability through the established internal security incident reporting channel. Option C. Immediately encrypt the sensitive data and remove it from the development database without informing anyone. Option D. Ignore the issue as it is in a development environment and not production, posing no immediate risk. The correct answer is C. Immediately encrypt the sensitive data and remove it from the development database without informing anyone. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the potential for data privacy violations and the ethical responsibility of a developer to secure sensitive information. The discovery of unencrypted sensitive customer data in a development environment, even if not production, carries significant risks. These risks include unauthorized access, potential data breaches, and non-compliance with data protection regulations. The developer must balance the urgency of fixing the issue with the need to follow established security protocols and reporting procedures. Correct approach analysis. The correct approach involves immediately reporting the vulnerability through the established internal channels. This aligns with best professional practices and regulatory expectations for data security. In the context of Oracle Cloud Infrastructure, OSI, development, this means adhering to OCI's security best practices and any company-specific security incident response plans. Prompt reporting ensures that the appropriate security teams are alerted, can assess the full scope of the risk, and can implement remediation measures effectively. This proactive stance minimizes potential harm to customers and the organization and demonstrates a commitment to data integrity and compliance with data protection principles, which are implicitly expected in cloud development environments. Incorrect approaches analysis. One incorrect approach is to attempt to fix the issue independently without reporting it. This is a regulatory and ethical failure because it bypasses established security protocols designed to manage and track vulnerabilities. It prevents a comprehensive risk assessment by security experts, potentially leaving other instances of the vulnerability unaddressed or leading to an incomplete fix. This can violate data protection regulations by failing to implement adequate security measures and by not having a documented incident response. Another incorrect approach is to ignore the issue, assuming it is contained within the development environment and poses no immediate threat. This is a severe ethical and regulatory failure. Development environments are not inherently secure, and vulnerabilities present there can be exploited. Ignoring the issue demonstrates a disregard for customer privacy and organizational security, potentially leading to a breach that violates data protection laws and erodes customer trust. It also fails to uphold the developer's professional responsibility to maintain secure systems. A third incorrect approach is to discuss the vulnerability with colleagues outside of the official reporting channels before reporting it. While collaboration is important, discussing sensitive security vulnerabilities in an informal manner can inadvertently spread awareness of the vulnerability without initiating the formal remediation process. This can lead to unauthorized attempts to fix the issue, potentially exacerbating the problem or creating new ones, and can be seen as a failure to follow proper incident management procedures, which are often mandated by regulatory frameworks for handling sensitive data. Professional reasoning. Professionals should adopt a report first, then act mindset for security vulnerabilities. This involves understanding and adhering to the organization's security incident response plan. When a vulnerability is discovered, the immediate step should be to document the finding, identify the affected systems and data, and report it through the designated channels, e.g., Security Operations Center, Incident Response Team. Following the guidance of the security team ensures that the remediation is handled systematically, securely, and in compliance with relevant regulations. This process prioritizes data protection and minimizes organizational risk. Question 10. System analysis indicates a developer is under significant pressure to deploy a new customer-facing application on Oracle Cloud Infrastructure, OSI, within an aggressive timeline. To meet this deadline, the developer is considering bypassing certain security configuration steps, such as disabling detailed logging for audit purposes and using broader network access rules than initially planned, arguing that these can be implemented post-deployment. The developer believes this will significantly accelerate the initial release. What is the most professionally responsible course of action? Option A. Deploy the application using default OCI security settings without any custom configurations, assuming they are sufficient for initial release. Option B. Focus solely on application functionality and performance, deferring all security and compliance considerations to a separate team after the initial deployment. Option C. Proceed with the accelerated deployment by disabling detailed logging and using broader network access rules, with the intention of addressing these security gaps in a subsequent patch. Option D. Implement the application with robust security configurations and necessary logging, even if it means a slight delay in the initial deployment, and communicate the rationale and risks of delay to stakeholders. The correct answer is D. Implement the application with robust security configurations and necessary logging, even if it means a slight delay in the initial deployment, and communicate the rationale and risks of delay to stakeholders. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data privacy and security, particularly when dealing with sensitive customer information. The developer is caught between a perceived business need for rapid deployment and the fundamental responsibility to adhere to established security protocols and regulatory requirements. The pressure to deliver quickly can create a conflict of interest, tempting shortcuts that could have severe consequences. Careful judgment is required to balance business objectives with legal and ethical mandates. Correct approach analysis. The correct approach prioritizes adherence to the Oracle Cloud Infrastructure, OSI, security best practices and relevant data protection regulations. This involves thoroughly understanding and implementing the security controls provided by OCI, such as identity and access management, EAM, policies, network security groups, and encryption. It also means ensuring that any data handling complies with applicable laws, which in the context of OCI development would typically align with general principles of data privacy and security common in cloud environments. This approach represents best professional practice because it upholds the trust placed in the developer and the organization by customers and stakeholders, minimizing the risk of data breaches, regulatory fines, and reputational damage. It demonstrates a commitment to responsible cloud development. Incorrect approaches analysis. Taking shortcuts with security configurations, such as disabling logging or using overly permissive access controls to speed up deployment, represents a direct violation of security best practices and potentially regulatory requirements for data protection and auditability. This failure to implement necessary security measures increases the risk of unauthorized access and data compromise. Deploying the application without proper data encryption, both in transit and at rest, exposes sensitive customer information to potential interception and theft. This is a significant breach of data privacy principles and likely contravenes data protection laws that mandate the safeguarding of personal data. Ignoring the need for proper access control reviews and relying solely on default configurations can lead to unintended data exposure. It fails to implement the principle of least privilege, a cornerstone of secure system design, and can result in unauthorized individuals or services gaining access to sensitive data. Professional reasoning. Professionals should employ a risk-based decision-making framework. This involves identifying potential security and privacy risks associated with development choices, assessing their likelihood and impact, and then implementing controls to mitigate those risks. When faced with pressure to expedite a deployment, developers should advocate for the necessary time to implement security measures correctly, rather than compromising them. If business pressures are insurmountable, they should escalate the concerns to management, clearly articulating the risks and potential consequences of deviating from security, best practices, and regulatory compliance. The principle of security by design and privacy by design should guide all development efforts. Question 11. The assessment process reveals that a critical customer-facing feature, designed to process sensitive personally identifiable information, PI, is scheduled for a rapid release. The development team lead is pushing for deployment within 24 hours, suggesting that the feature's existing code has undergone basic unit testing and that a full security review can be deferred until after the release. As the developer responsible for implementing key components of this feature, you have concerns about potential vulnerabilities that might not be caught by unit tests alone, especially concerning data handling and access controls within the Oracle Cloud Infrastructure environment. What is the most professionally responsible course of action? Option A. Deploy the feature and document your concerns in the release notes, trusting that the operations team will be vigilant in monitoring for any security anomalies. Option B. Lightly but firmly refuse to deploy the feature until a comprehensive security review, including penetration testing and vulnerability scanning, is completed and all identified critical or high-severity issues are remediated. Option C. Deploy the feature but immediately implement additional ad hoc security monitoring tools that were not part of the original plan, hoping to catch any issues in real time. Option D. Proceed with the deployment as requested, assuming that the Oracle Cloud Infrastructure's inherent security features will mitigate any unforeseen risks and address any security concerns post-release. The correct answer is D. Proceed with the deployment as requested, assuming that the Oracle Cloud Infrastructure's inherent security features will mitigate any unforeseen risks and address any security concerns post-release. Explanation. The assessment process reveals a common ethical dilemma in cloud development, balancing the urgency of a feature release with the responsibility to secure sensitive data. In this scenario, the developer is pressured to deploy a new feature that handles customer personally identifiable information, PI, without completing a thorough security review. This creates a conflict between business objectives and the ethical obligation to protect user data, which is paramount in cloud environments. The challenge lies in navigating this pressure while upholding professional standards and regulatory compliance. The correct approach prioritizes data security and regulatory compliance over immediate feature deployment. This aligns with the principle of security by design and the ethical duty of a developer to protect user data. In the context of Oracle Cloud Infrastructure, OSI, and general data protection principles, failing to adequately secure PII can lead to severe consequences, including data breaches, reputational damage, and significant legal penalties under various data privacy regulations. A developer's professional responsibility includes ensuring that security measures are robust and validated before exposing sensitive data to any new functionality. An incorrect approach that bypasses security reviews for expediency is professionally unacceptable. It demonstrates a disregard for data privacy and security best practices. Such an action could violate implicit or explicit contractual obligations with customers regarding data protection and could contravene data privacy laws that mandate reasonable security measures for PII. This approach prioritizes short-term business goals over long-term trust and legal compliance, creating a significant risk for the organization and its users. Another incorrect approach might involve assuming that existing security controls are sufficient without explicit verification for the new feature. While OCI provides robust security services, each new application or feature introduces unique attack vectors. Relying on assumptions without due diligence is a failure of professional responsibility. It can lead to vulnerabilities that are not covered by general security measures, leaving PII exposed. The professional decision-making process in such situations should involve 1. Identifying the ethical conflict, pressure to deploy VS, responsibility to secure data. 2. Consulting relevant policies and regulations, understanding data protection requirements and organizational security standards. 3. Communicating risks clearly, articulating the potential consequences of bypassing security reviews to stakeholders. 4. Escalating the issue, if pressure persists, involving management or security teams to ensure proper decision-making. 5. Prioritizing security, advocating for the completion of necessary security reviews before deployment, even if it causes delays. Question 12. During the evaluation of a project requiring the migration of sensitive customer personally identifiable information, PI, to Oracle Cloud Infrastructure, which approach best ensures compliance with data protection regulations and maintains data integrity? Option A. Proceed with the migration to the nearest OCI region to minimize latency, relying on OCI's default security configurations without specific verification against the customer's data privacy policies. Option B. Conduct a thorough assessment of the customer's data residency requirements and applicable data protection laws. Choose an OCI region that satisfies these requirements and implement comprehensive encryption for data at rest and in transit, utilizing OCI Vault for key management. Option C. Select the OCI region with the lowest cost and assume Oracle's global infrastructure inherently meets all data residency requirements. Implement encryption only for data in transit. Option D. Migrate the data to an OCI region outside the customer's primary jurisdiction to leverage potentially lower storage costs, and document the decision as a business expediency. The correct answer is C. Select the OCI region with the lowest cost and assume Oracle's global infrastructure inherently meets all data residency requirements. Implement encryption only for data in transit. Explanation. Scenario analysis. This scenario presents a common challenge for Oracle Cloud Infrastructure developers, ensuring data privacy and compliance when migrating sensitive customer data to the cloud. The professional challenge lies in balancing the benefits of cloud scalability and accessibility with the stringent requirements of data protection regulations. Developers must understand not only the technical aspects of data migration, but also the legal and ethical implications of handling personal information in a cloud environment. This requires careful consideration of data residency, access controls, encryption, and the shared responsibility model inherent in cloud services. Correct approach analysis. The correct approach involves a thorough understanding and application of Oracle Cloud Infrastructure's security and compliance features, specifically focusing on data residency and encryption. This aligns with the principles of data protection by design and by default, which are fundamental to many regulatory frameworks. By selecting an OCI region that meets the customer's data residency requirements and implementing robust encryption for data at rest and in transit, the developer demonstrates a commitment to safeguarding sensitive information. This proactive stance minimizes the risk of regulatory noncompliance and builds customer trust. The use of OCI Vault for managing encryption keys further enhances security by centralizing and protecting sensitive credentials. Incorrect approaches analysis. An approach that prioritizes cost savings by selecting the cheapest OCI region without verifying its compliance with data residency laws is a significant regulatory failure. This demonstrates a disregard for data protection obligations and could lead to severe penalties, including fines and reputational damage. Ethically, it breaches the trust placed in the developer to handle data responsibly. Another incorrect approach is to assume that OCI's default security settings are sufficient for all types of sensitive data. While OCI offers strong security, specific data types may have unique compliance requirements, e.g., healthcare data, financial data, that necessitate custom configurations, such as enhanced access controls or specific encryption algorithms. Failing to implement these tailored measures can result in non-compliance and data breaches. Finally, neglecting to implement encryption for data at rest, even if data is in transit, is a critical security and regulatory oversight. Data at rest is vulnerable to unauthorized access if storage media is compromised, or if access controls are bypassed. This failure directly contravenes best practices for data protection and regulatory mandates that require data to be secured in all states. Professional reasoning. Professionals should adopt a risk-based approach to data migration. This involves identifying the type of data being handled, understanding the relevant regulatory landscape, e.g., GDPR, CCPA, or specific industry regulations, and then selecting OCI services and configurations that meet those requirements. A key step is to consult OCI's compliance documentation and engage with security and legal teams to ensure all obligations are met. Prioritizing compliance and security over immediate cost savings is a hallmark of professional integrity and responsible cloud development. Question 13. The control framework reveals that a critical OCI application is experiencing performance bottlenecks during peak usage. To address this, a development team is considering several strategies to optimize its processes, which approach best aligns with professional best practices for cloud application optimization. Option A. Conduct a thorough performance analysis to establish baseline metrics, identify specific bottlenecks, and then iteratively implement and test optimization strategies. Option B. Implement a new caching mechanism and immediately deploy it to production to reduce latency. Option C. Focus exclusively on reducing the number of API calls to minimize network traffic without assessing the impact on data retrieval speed. Option D. Re-architect the entire application's data storage layer to a different OCI service without prior load testing or rollback plan. The correct answer is B. Implement a new caching mechanism and immediately deploy it to production to reduce latency. Explanation. The scenario presents a common challenge in cloud development, optimizing processes for efficiency and cost-effectiveness while adhering to established best practices and potential regulatory considerations. The professional challenge lies in balancing the immediate need for performance gains with the long-term implications of architectural choices and the potential for introducing unintended complexities or security vulnerabilities. Careful judgment is required to select an optimization strategy that is both effective and sustainable. The correct approach represents best professional practice because it prioritizes a systematic, data-driven methodology. By first establishing baseline metrics, developers can accurately measure the impact of any optimization. Iterative refinement, guided by performance monitoring and testing, ensures that changes are effective and do not introduce regressions. This aligns with the principles of continuous improvement and robust software development lifecycle management, which are implicitly expected in professional cloud development. While the 1Z0-1084-21 exam focuses on Oracle Cloud Infrastructure, OSI development, the underlying principles of process optimization are universal and align with general IT best practices that would be expected of a certified professional. There are no specific US or UK regulations directly dictating the asterisk methodology asterisk of process optimization in cloud development at this granular level, but the principles of due diligence, risk management, and delivering reliable services are universally applicable professional standards. An incorrect approach that focuses solely on implementing a new, unproven technology without prior analysis risks introducing instability and unforeseen costs. This could lead to a failure to meet service level agreements (SLAs) and potentially violate contractual obligations with stakeholders, representing a professional failure in due diligence and risk management. Another incorrect approach, such as optimizing only for cost reduction without considering performance implications, could lead to a degraded user experience and reduced application effectiveness, failing to meet the core business objectives of the application. This demonstrates a lack of holistic understanding of process optimization. A third incorrect approach, which involves making significant architectural changes without thorough testing and validation, introduces a high risk of system failure and data integrity issues, which is a direct contravention of professional responsibility to deliver stable and reliable systems. Professionals should approach process optimization by first understanding the current state through measurement and analysis. Then they should identify specific areas for improvement, hypothesize potential solutions, and implement them in a controlled, iterative manner. Continuous monitoring and validation are crucial to ensure that optimizations achieve their intended goals without negative side effects. This systematic approach minimizes risk and maximizes the likelihood of successful and sustainable process improvements. Question 14. Cost-benefit analysis shows that a new OCI application needs to securely manage sensitive customer data and API credentials. The development team is under pressure to launch quickly. Which approach best balances rapid deployment with robust security and compliance within the OCI framework? Option A. Utilize OCI Vault for secrets management and OCI Identity and Access Management (IAM) for granular access control to resources. Option B. Develop a custom encryption solution for all sensitive data and manage access through application-level logic. Option C. Store API keys and database connection strings directly within the application's source code and configuration files. Option D. Hardcode access policies directly into the application logic, granting broad permissions to necessary OCI resources. The correct answer is A. Utilize OCI Vault for secrets management and OCI Identity and Access Management (IAM) for granular access control to resources. Explanation. Scenario analysis. This scenario presents a common challenge for OCI developers, balancing the immediate need for rapid development and feature deployment with the long-term implications of technical debt and security vulnerabilities. The pressure to deliver quickly can lead to shortcuts that, while seemingly efficient in the short term, can introduce significant risks and costs down the line. The professional challenge lies in advocating for sustainable development practices that align with OCI best practices and security standards, even when faced with competing priorities. This requires strong communication skills, a deep understanding of OCI services, and the ability to articulate the risks associated with suboptimal choices. Correct approach analysis. The correct approach prioritizes the secure and efficient use of OCI services by leveraging managed services and adhering to OCI best practices for data handling and access control. Specifically, using OCI Vault for secrets management and OCI Identity and Access Management (IAM) for granular permissions directly addresses the security and compliance requirements inherent in cloud development. This aligns with the principle of least privilege, a fundamental security tenet, and reduces the operational burden of managing security configurations manually. By utilizing these managed services, the development team benefits from Oracle's built-in security and compliance features, which are continuously updated and maintained, thereby minimizing the risk of misconfiguration and potential data breaches. This approach demonstrates professional responsibility by proactively mitigating risks and ensuring the long-term integrity and security of the application and its data within the OCI environment. Incorrect approaches analysis. Storing sensitive credentials directly in application code or configuration files represents a significant security failure. This practice violates the principle of least privilege and exposes critical information to unauthorized access if the code repository or deployment artifacts are compromised. It also creates a compliance risk, as many regulations mandate the secure management of sensitive data. Implementing custom encryption for secrets without leveraging OCI's native security services is another failure. While well-intentioned, custom encryption solutions are often complex to implement correctly, prone to subtle vulnerabilities, and require ongoing maintenance and patching. This increases the development overhead and introduces a higher risk of security flaws compared to using battle-tested managed services like OCI Vault. Furthermore, it bypasses the integrated security and auditing capabilities provided by OCI. Hard-coding access policies directly into the application logic, rather than using OCI IAM, is a failure in adhering to cloud-native security principles. This approach tightly couples application functionality with infrastructure access, making it difficult to manage, update, and audit permissions independently. It also negates the benefits of OCI IAM centralized policy management, role-based access control, and dynamic policy updates, leading to potential security gaps and operational inefficiencies. Professional reasoning. Professionals should adopt a risk-based approach, continuously evaluating the trade-offs between speed and security/sustainability. This involves understanding the OCI service catalog and its security features, advocating for the use of managed services where appropriate, and clearly communicating the potential risks and benefits of different technical decisions to stakeholders. A robust decision-making process includes 1. Identifying all potential security and operational risks associated with a proposed solution. 2. Evaluating the available OCI services and best practices that can mitigate these risks. 3. Assessing the long-term cost and maintenance implications. And 4. Prioritizing solutions that align with organizational security policies and regulatory requirements. Question 15. Benchmark analysis indicates that a critical customer-facing application on Oracle Cloud Infrastructure needs a rapid feature update to meet a competitive market window. A key stakeholder is pushing for the fastest possible deployment, suggesting that security configurations for sensitive customer data can be addressed after the initial release. As an OCI developer, what is the most professionally responsible approach to balance the stakeholders' urgency with the imperative of data security and compliance? Option A. Integrate robust security measures, including appropriate access controls and data encryption, into the development and testing cycles for the new features, even if it means a slight delay in the initial deployment, and communicate the security rationale to the stakeholder. Option B. Proceed with the deployment as requested by the stakeholder, assuming that OCI's inherent security features will adequately protect the data until a later security review can be conducted. Option C. Implement the new features with minimal security checks during development, prioritizing the rapid deployment, and schedule a comprehensive security review and remediation plan for the post-deployment phase. Option D. Focus solely on the functional aspects of the new features to meet the deadline, documenting the security concerns as a separate, lower priority task to be addressed by a different team at an unspecified future date. The correct answer is C. Implement the new features with minimal security checks during development, prioritizing the rapid deployment, and schedule a comprehensive security review and remediation plan for the post-deployment phase. Explanation. Scenario analysis. This scenario presents a professional challenge for an Oracle Cloud Infrastructure (OCI) developer by requiring them to balance the immediate need for rapid feature deployment with the long-term implications of data security and compliance within the Oracle Cloud environment. The stakeholders' pressure for speed, while understandable from a business perspective, can create a conflict with the developer's responsibility to adhere to OCI's security best practices and potentially relevant data privacy regulations. The challenge lies in navigating this pressure without compromising the integrity and security of sensitive customer data, which could lead to significant financial penalties and reputational damage. Correct approach analysis. The correct approach emphasizes a proactive and integrated security strategy. By incorporating security considerations early in the development lifecycle, such as implementing robust access control mechanisms and data encryption at rest and in transit, the developer aligns with OCI's shared responsibility model and best practices for data protection. This approach demonstrates professional integrity by prioritizing security and compliance, which are fundamental to building trust with customers and avoiding regulatory breaches. It also aligns with the principle of security by design, a cornerstone of modern cloud development, ensuring that security is not an afterthought but an intrinsic part of the solution. Incorrect approaches analysis. One incorrect approach involves deferring security implementation to a later stage, such as post-deployment. This is a significant regulatory and ethical failure because it exposes sensitive data to unnecessary risks during the development and initial deployment phases. It violates the principle of least privilege and adequate protection, potentially contravening data privacy regulations that mandate timely and effective security measures. Another incorrect approach, focusing solely on meeting the stakeholders' immediate deployment deadline without any security validation, represents a critical ethical lapse. This prioritizes expediency over responsibility, leading to a high probability of security vulnerabilities and non-compliance. It demonstrates a disregard for the potential harm to customers and the organization, which is professionally unacceptable and could lead to severe legal and financial repercussions. Professional reasoning. Professionals should adopt a risk-based decision-making framework. This involves identifying potential security and compliance risks associated with development choices, assessing their impact, and implementing appropriate controls. When faced with stakeholder pressure, developers should clearly communicate the security implications and regulatory requirements, advocating for a balanced approach that meets business objectives without compromising security. This often involves proposing phased security implementations or alternative solutions that can achieve both speed and security. Maintaining open communication and documenting all security decisions and justifications are crucial for professional accountability. Question 16. Governance review demonstrates that a new feature being developed by an OCI developer will ingest and process sensitive customer data in a manner not explicitly covered by current organizational data handling policies. The developer has the technical capability to implement the feature as requested, but the data processing method introduces new considerations for data privacy and security. What is the most professional and compliant course of action? Option A. Immediately halt development of the feature and await explicit written instructions from the governance team on how to proceed, even if it causes significant project delays. Option B. Implement the feature using the most technically efficient method available and document the data handling process in the code comments for future reference by the governance team. Option C. Engage with the OCI security and governance teams to discuss the new data handling requirements, understand potential risks, and collaboratively determine the most secure and compliant implementation approach, or initiate a formal policy exception process if necessary. Option D. Proceed with implementing the feature as requested, assuming existing security controls will adequately protect the data, and inform the governance team after deployment. Correct answer is D. Proceed with implementing the feature as requested, assuming existing security controls will adequately protect the data, and inform the governance team after deployment. Explanation. Scenario analysis. This scenario presents a common challenge in cloud development where a new feature, while technically feasible and potentially beneficial, introduces new data handling requirements that may not align with existing governance policies. The challenge lies in balancing innovation and speed to market with the imperative to maintain compliance and security, especially concerning sensitive data. The developer must navigate the tension between delivering a requested feature and adhering to established organizational controls and regulatory obligations. Correct approach analysis. The correct approach involves proactively engaging with the governance and security teams to understand the implications of the new data handling requirements. This demonstrates a commitment to responsible development and adherence to the principle of security by design. By seeking clarification and proposing solutions that align with existing policies or initiating a formal process for policy exception or update, the developer upholds regulatory compliance and organizational integrity. This aligns with best practices in cloud governance, which emphasize collaboration, transparency, and risk mitigation. Specifically, within the context of Oracle Cloud Infrastructure, OSI, and its associated security and compliance frameworks. This approach ensures that data protection measures, access controls, and auditing capabilities are considered and implemented appropriately before deployment, preventing potential breaches or non-compliance. Incorrect approaches analysis. Proceeding with the feature without consulting governance or security teams represents a significant regulatory and ethical failure. It bypasses established controls designed to protect sensitive data and ensure compliance with relevant regulations, e.g., data privacy laws. This approach risks data exposure, unauthorized access, and potential penalties for noncompliance. Deploying the feature with a hope for the best attitude, assuming existing controls are sufficient, is also a failure. It demonstrates a lack of due diligence and a disregard for the potential risks associated with handling sensitive data in a new manner. This can lead to unforeseen vulnerabilities and a breach of trust with stakeholders and customers. Implementing the feature and then retrospectively informing governance teams without prior consultation is a reactive and irresponsible approach. It implies that compliance is an afterthought rather than an integral part of the development lifecycle. This can lead to costly remediation efforts, reputational damage, and a breakdown in the collaborative governance process. Professional reasoning. Professionals should adopt a proactive and collaborative approach to cloud development. When faced with new requirements that impact data handling or security, the decision-making process should involve 1. Understanding the new requirements and their potential impact. 2. Consulting relevant governance, security, and compliance policies and teams. 3. Identifying potential risks and proposing mitigation strategies. 4. Seeking formal approval or guidance for any deviations from existing policies. 5. Documenting all decisions and actions taken. This framework ensures that innovation is pursued responsibly, with a strong emphasis on maintaining security, compliance, and ethical standards throughout the development lifecycle. Question 17. The risk matrix shows a high likelihood of unauthorized access to sensitive customer data if the new microservices data storage and access controls are not robustly implemented. As an OCI developer, which approach best mitigates this risk while adhering to data privacy best practices? Option A. Defer the implementation of advanced encryption and granular access controls until after the microservice has been deployed and is in production, to expedite the initial release. Option B. Implement basic network security groups for the microservice and assume that application-level security will be sufficient to prevent unauthorized access to sensitive data. Option C. Utilize OCI object storage with server-side encryption enabled and implement fine-grained OCI identity and access management (IAM) policies to enforce the principle of least privilege for data access. Option D. Store data in OCI object storage without encryption and rely solely on application-level authentication and authorization mechanisms for data protection. Correct answer is C. Utilize OCI object storage with server-side encryption enabled and implement fine-grained OCI identity and access management (IAM) policies to enforce the principle of least privilege for data access. Explanation. Scenario analysis. This scenario presents a professional challenge for an Oracle Cloud Infrastructure (OSI) developer concerning the implementation of a new microservice that handles sensitive customer data. The challenge lies in balancing the need for rapid development and deployment with the stringent requirements of data privacy regulations. The developer must ensure that the chosen data storage and access control mechanisms not only meet functional requirements, but also comply with applicable laws, which can be complex and have significant legal and financial repercussions if violated. The risk matrix highlights potential vulnerabilities, demanding a proactive and compliant approach. Correct approach analysis. The correct approach involves selecting OCI services that inherently support data encryption at rest and in transit, and implementing granular identity and access management (IAM) policies. This aligns with the principle of security by design and privacy by design, which are fundamental to many data protection regulations. For instance, OCI object storage offers server-side encryption by default. An OCI vault can be used for managing encryption keys. Implementing IAM policies ensures that only authorized personnel and services can access the sensitive data, directly addressing requirements for data access control and minimization. This proactive stance minimizes the risk of data breaches and noncompliance, representing best professional practice by embedding security and privacy into the core architecture. Incorrect approach is analysis. One incorrect approach is to prioritize performance and cost-effectiveness by opting for unencrypted storage and relying solely on application-level security. This fails to meet regulatory mandates for data protection, such as those requiring encryption of sensitive data at rest. It creates a significant vulnerability, as any compromise of the application layer could expose the data. Another incorrect approach is to implement basic access controls without considering the principle of least privilege. This could grant broader access than necessary, increasing the attack surface and violating data minimization principles. A third incorrect approach is to defer security and compliance considerations to a later stage, assuming they can be retrofitted. This is a common pitfall that leads to costly rework and potential regulatory penalties, as compliance is often a foundational requirement, not an add-on. Professional reasoning. Professionals should adopt a risk-based approach, starting with a thorough understanding of the data's sensitivity and the relevant regulatory landscape. For selecting OCI services, they must assess how each service's features align with compliance requirements for data protection, encryption, access control, and auditing. The decision-making process should involve consulting with security and legal teams to ensure all regulatory obligations are understood and addressed. Prioritizing compliance from the outset, rather than as an afterthought, is crucial for building secure and trustworthy cloud solutions. Question 18. Strategic planning requires a developer to implement a new microservice on Oracle Cloud infrastructure that will process sensitive customer data. Given the critical nature of this data, which approach best ensures both security and compliance with relevant U.S. federal regulations throughout the development lifecycle? Option A. Delegate all security and compliance responsibilities to a separate security team, allowing the development team to focus solely on functional requirements. Option B. Design and develop the microservice with security and compliance requirements integrated from the outset, incorporating regular security reviews, adherence to OCI security best practices, and validation against applicable U.S. federal regulations at each development stage. Option C. Implement the microservice with a focus on rapid deployment, relying on post-deployment automated security scans to identify and remediate any vulnerabilities. Option D. Prioritize feature development and assume that Oracle Cloud Infrastructure's inherent security features will adequately protect the sensitive customer data without additional developer-imposed controls. The correct answer is C. Implement the microservice with a focus on rapid deployment, relying on post-deployment automated security scans to identify and remediate any vulnerabilities. Explanation. The scenario presents a common challenge for Oracle Cloud infrastructure developers, balancing the need for rapid feature deployment with the imperative to maintain robust security and compliance. The professional challenge lies in the inherent tension between agility and security. Developers are often pressured to deliver new functionalities quickly, which can lead to shortcuts in security implementation or a lack of thorough validation against regulatory requirements. Careful judgment is required to ensure that neither security nor compliance is compromised in the pursuit of speed. The correct approach represents best professional practice because it prioritizes a proactive and integrated security and compliance strategy. By embedding security and compliance considerations from the initial design phase and continuously validating against the relevant Oracle Cloud infrastructure, OCI, security best practices, and any applicable U.S. federal regulations, as implied by the exam's focus on a U.S. context for cloud development, the team ensures that security is not an afterthought. This aligns with the principle of security by design and demonstrates a commitment to responsible cloud development, minimizing the risk of breaches and regulatory penalties. An incorrect approach that overlooks the need for continuous monitoring and validation against OCI security, best practices, and U.S. federal regulations would represent a significant regulatory and ethical failure. This failure stems from a disregard for established security protocols and legal obligations, potentially exposing sensitive data to unauthorized access and leading to noncompliance with data protection laws. Another incorrect approach, such as relying solely on automated security scans without human oversight and expert review, is also professionally unacceptable. While automation is valuable, it cannot replace the nuanced understanding and critical thinking required to interpret scan results in the context of specific application logic and evolving threat landscapes, nor can it fully address the complexities of regulatory interpretation. This approach risks overlooking subtle vulnerabilities or misinterpreting compliance requirements. Professionals should employ a decision-making framework that begins with clearly defining the project's security and compliance requirements based on the data being handled and the intended audience. This should be followed by an iterative process of design, implementation, testing, and validation, where security and compliance checks are integrated at each stage. Regular consultation with security experts and legal counsel, where applicable, is crucial. Finally, a commitment to continuous learning and adaptation to new threats and regulatory changes is essential for maintaining a secure and compliant cloud environment. Question 19. The efficiency study reveals that a new customer-facing feature requires programmatic access to sensitive customer billing information stored within OCI object storage. The development team needs to ensure this access is secure and compliant with data handling best practices. Which OCI IAM strategy best supports the principle of least privilege for this application service identity? Option A. Grant the application service identity permissions to access all buckets within the tenancy, allowing it to read any object. Option B. Create a custom IAM policy that grants the application service identity-specific permissions to read and list objects within the designated billing data bucket, and deny all other actions. Option C. Embed the OCI API keys directly within the application's configuration files, allowing it to authenticate with broad permissions. Option D. Assign the application service identity to the administrators group, granting it full administrative privileges across all OCI resources. The correct answer is B. Create a custom IAM policy that grants the application service identity-specific permissions to read and list objects within the designated billing data bucket and deny all other actions. Explanation. The scenario presents a common challenge in cloud development, balancing the need for rapid feature deployment with the imperative to maintain robust security and compliance. The developer is tasked with implementing a new feature that requires access to sensitive customer data, necessitating careful consideration of data handling and access control mechanisms within Oracle Cloud Infrastructure, OCI. The professional challenge lies in selecting the most appropriate OCI identity and access management (IAM) strategy that adheres to the principle of least privilege while enabling the feature's functionality, all within the context of the exam's implied regulatory framework, which prioritizes data protection and secure access. The correct approach involves leveraging OCI IAM policies to grant specific, granular permissions to the application service identity. This aligns with the principle of least privilege, a fundamental tenet of secure cloud architecture and a common requirement in regulatory frameworks governing data handling. By defining policies that allow only the necessary actions on specific resources, the developer minimizes the attack surface and reduces the risk of unauthorized data access or modification. This proactive security measure is crucial for maintaining compliance with data privacy regulations and ensuring the integrity of customer information. An incorrect approach would be to grant overly broad permissions, such as assigning the application service identity to a group with administrative privileges, or allowing unrestricted access to all customer data resources. This directly violates the principle of least privilege and creates significant security vulnerabilities. Such an approach would be professionally unacceptable as it exposes sensitive data to unnecessary risk, potentially leading to data breaches and noncompliance with data protection laws. Another incorrect approach would be to bypass OCI IAM altogether and embed credentials directly within the application code. This is a critical security flaw, as it hardcodes sensitive information, making it easily discoverable if the code is compromised. This practice is universally condemned in secure development and would represent a severe ethical and regulatory failure, as it demonstrates a disregard for basic security best practices and data confidentiality. Professionals should employ a decision-making framework that prioritizes security and compliance from the outset. This involves understanding the data sensitivity, the application's functional requirements, and the available OCI IAM tools. The process should include 1. Threat modeling, identifying potential risks associated with data access. 2. Requirement analysis, clearly defining what actions the application needs to perform. 3. IAM policy design, crafting granular policies that grant only the minimum necessary permissions. 4. regular review and auditing, continuously monitoring access logs and policy effectiveness. This systematic approach ensures that security and compliance are integrated into the development lifecycle, rather than being an afterthought. Question 20. Assessment of the most appropriate OCI service and security configuration for storing and processing sensitive customer personal identifiable information, PI, that requires encryption at rest and in transit, while adhering to data privacy regulations, considering the developer's primary responsibility is to ensure data confidentiality and integrity. Option A. Storing PII directly within OCI compute instances, relying solely on application-level encryption. Option B. Utilizing OCI Relational Database Service, RDS, with default security settings for all PII data. Option C. Storing PII directly within OCI functions, assuming data is only accessed during function execution. Option D. OCI object storage with server-side encryption enabled and access controlled via IAM policies, potentially integrating with OCI Vault for key management. The correct answer is D. OCI object storage with server-side encryption enabled and access controlled via IAM policies, potentially integrating with OCI Vault for key management. Explanation. Scenario analysis. This scenario presents a common challenge for OCI developers, balancing the need for rapid feature deployment with the imperative to maintain data privacy and security, especially when dealing with sensitive customer information. The challenge lies in identifying the most appropriate OCI service for storing and processing this data, considering the regulatory landscape that governs data handling. A misstep here can lead to compliance violations, data breaches, and significant reputational damage. The developer must navigate the complexities of OCI's service offerings and understand their implications within the context of data protection regulations. Correct approach analysis. The correct approach involves leveraging OCI object storage with appropriate encryption and access controls, and potentially integrating with OCI Vault for key management. This aligns with best practices for storing unstructured or semi-structured sensitive data. Object storage is designed for durability and scalability, and when combined with server-side encryption, SSE, or client-side encryption, it provides a robust foundation for data protection. OCI Vault further enhances security by allowing developers to manage encryption keys securely, ensuring that only authorized entities can decrypt the data. This approach directly addresses the need to protect sensitive customer information while enabling efficient access for authorized applications, thereby adhering to the principles of data minimization and security by design, which are fundamental to data protection regulations. Incorrect approach is analysis. Storing sensitive customer data directly in OCI compute instances without robust encryption or access controls is a significant regulatory and ethical failure. This exposes the data to unauthorized access if the instance is compromised, violating principles of data confidentiality and integrity. Furthermore, relying solely on application-level encryption without leveraging OCI's built-in security features increases the risk of key management vulnerabilities and makes auditing more complex, potentially contravening compliance requirements. Using OCI Relational Database Service, RDS, for all sensitive data, regardless of its structure, can also be problematic. While RDS offers security features, it might not be the most cost-effective or performant solution for large volumes of unstructured or infrequently accessed sensitive data. More importantly, if the RDS instance is not adequately secured with encryption at rest and in transit, and if granular access controls are not implemented, it can lead to similar data protection failures as the compute instance approach. The regulatory implication is a failure to implement appropriate technical and organizational measures to ensure a level of security appropriate to the risk. Choosing OCI functions for direct data storage without an accompanying persistent storage solution is fundamentally flawed. Functions are designed for ephemeral, event-driven compute and are not intended for long-term data persistence. Storing sensitive data within the function's execution environment would result in data loss upon function termination and would be a severe security risk, as the data would be exposed during execution and potentially logged or cached inappropriately, leading to a clear breach of data confidentiality and integrity principles. Professional reasoning. Professionals should adopt a data-centric security approach. This involves understanding the sensitivity and nature of the data being handled, Identifying relevant regulatory requirements, e.g., GDPR, CCPA, HIPAA, depending on the jurisdiction and data type, and then selecting OCI services that inherently support these requirements. A decision-making framework should include 1. Data classification. Categorize data based on sensitivity. 2. Risk assessment. Evaluate potential threats and vulnerabilities. 3. Compliance mapping. Identify applicable regulations and their specific mandates. 4. Service selection. Choose OCI services that best meet security, privacy, and performance needs, prioritizing those with built-in encryption, access control, and auditing capabilities. 5. Implementation and validation. Securely configure chosen services and regularly audit their effectiveness.